Hello everyone, in this lecture we're going to talk about climate change. In the first section we're going to talk about global warming and its significance. Then we will discuss the direct impacts of global warming on human health, such as extreme heat and natural disasters like hurricane, floods, and droughts. And in the last section we will talk about the indirect effects of global warming on human health, such as vector-borne disease, waterborne disease, food-borne disease, allergic illnesses, and malnutrition. Global warming is a controversial and hot topic in environmental health. Almost every day we hear in the news about global warming and the consequences of global warming, like the hottest years in history occurred in 21st century, and almost all hottest years were after 2000. Or malaria increase in different parts of the world, or heat wave that has caused icebergs melting in Arctic, and so forth. So there are two important concepts in global warming that are frequently used interchangeably, but these terms are not synonyms at all, and they are actually very different. Weather refers to the short-term meteorological variations like daily or weekly temperature, precipitation, humidity, and wind, and it's for a small local region. On the other hand, climate refers to the long-term variations, like yearly, decade, century of the temperature, precipitation, humidity, and wind. And it refers to a large area, for example, average temperature in United States from 2000 to today. So weather changes a lot from day to day, but climate remains almost constant in short term. Global warming is a fact because it has measurable impacts on the planet. One of the obvious effects of global warming is temperature rise around the world from North Pole to South Pole. This figure shows temperature anomaly, which is the difference of temperature from average or baseline. A negative temperature anomaly indicates cooler than average, and a positive temperature anomaly shows warmer than average. In the year 1880, it was the anomaly was negative 0.3, which is cooler than average, but now it is almost 0.5 warmer than average, which is, so the difference is 0.74 degrees centigrade increase compared to the baseline. Also here, blue lines indicates global annual average of temperature from 1880, and the red line is the 5-year average of global temperature. You can see 5-year average of temperature has progressively increased, especially after the year 1960, which is corresponds to the industrialization. As you can see in this figure, the climate data started at 1880 because there are no data before 1880, and data documentation of temperature began in 1880. Scientists believe that a possible cause of global warming is increase of emission of greenhouse gases such as carbon dioxide, which is the result of human activities like deforestation and fossil fuel. Other gases are water vapor, methane, which is also known as natural gas, ozone, and CFC. So these gases are the main greenhouse gases that contribute to global warming. Greenhouse gases get their name from greenhouse. If you have ever been in a greenhouse, even though it's cold outside, it's warm inside. So the way that it works is that the earth gets the energy from the sun. Some sunlight that hit the earth is reflected by light objects like snow, clouds, or mirror. So these greenhouse gases hold or trap more heat in the atmosphere for a longer period of time. According to comprehensive assessment of IPCC, which examines the science related to climate change and releases reports every 5 to 7 years. It is projected that global temperature to be increased between 3.6 degree to 7 degree Fahrenheit at the end of this century, depending on different scenarios. Under the first scenario, which is high emission of the greenhouse gases, so it is predicted that the temperature will increase to almost 7 degree Fahrenheit. Under middle emission scenario of greenhouse gases, it will increase by almost 5 degree Fahrenheit. And under low emission greenhouse gases scenario, it will increase by almost 3.6 degree Fahrenheit. This chart also shows that after industrialization, emission of the CO2 or carbon dioxide, which is one of the main greenhouse gases, increased, most likely because of burning fossil fuels used in cars, industry, and deforestation means clear cutting forests and replacing them with other land use, non-federal areas. Deforestation will increase the amount of CO2 because plants or vegetation during photosynthesis absorb carbon dioxide in the air and convert it to the oxygen. But after deforestation, we won't have plants to reduce the carbon dioxide in the air. Unfortunately, extensive areas of the world have been affected by deforestation, especially in the Amazon, which covers almost 31% of the total forest areas, and particularly in recent years. Another area affected by deforestation is U.S. Pacific Northwest in Washington state, mainly due to logging and wildfires. So this map shows the prediction of global warming across the globe between the year 2070 and 2100 relative to the average temperature from 1960 to 1990. So 30 years in future temperature was compared with 30 years in past temperature as baseline. As you can see, it is projected that in South America and Arctic areas will have highest temperature rise, almost 7 to 8 degree temperature rise. So temperature rise is not equally distributed across the globe. Some areas will be more affected, some areas will be less affected. And this map is based on the HAD-CM3 climate model as is used by IPCC. Now let's move on to talk about direct impact of climate change on human health. Direct impact of global warming on human health is generally classified into two categories: extreme heat, such as heat wave and wildfire, and natural disasters such as hurricane, drought, and flood. So let's first talk about extreme heat. The first consequence of extreme heat is heat wave, which is a period 2 or more days of excessively hot temperature compared to the usual weather. During heat wave, it is hard for human body to maintain its temperature in the normal range. Two examples of heat waves are Chicago heat wave in the year 1995 that more than 700 people died in only 5 days, and also another historical disaster which we are familiar with, that is European heat wave in the year 2003 that killed between 50 to 70,000 people. Let's look at heat wave in European countries in the year 2003, which is recorded as the hottest summer in Europe. The effect of heat wave was terrible in France, that killed over 14,000 people only in this country. And the temperature remained around 100 Fahrenheit for more than a week in August. In Portugal, it caused forest fire, and because of dry condition, over 200,000 hectares of forest area burned. In Switzerland, it caused melting glaciers and avalanches. Alpine glacier shrank by 10%. In Germany, lowest river level in the century was observed, and in the UK, it caused train rails buckle because of heat wave. It is also projected that US will see unprecedented heat waves by mid-century based on the models, especially in Phoenix, if the governments continue emission of greenhouse gases. Another consequence of extreme heat is wildfire, which is uncontrolled fire, especially in rural areas, and is mostly caused by human activities like discarding cigarette in forests, camping, arson. So it has been reported a fourfold increase in occurrence of western wildfire within 20 years ago, particularly in the state of California, and it is evident that wildfire also causes air pollution because the smoke and other particles emitted from fire, which can also have adverse effects on lungs and heart condition, and may cause other respiratory diseases like asthma and bronchitis. So wildfire is associated with adverse health outcomes. Researchers have predicted more wildfires by 2050, especially during August because of higher average temperature. This figure shows predictions of percentage increase in areas that will burn in mid-21st century compared to the year 2000. As you can see, some areas will have very high increase in burning, almost 100% increase in burning in mid-21st century, and some areas have 20 to 30% burning compared to the year 2000. Another direct impact of global warming on human health is several natural disasters. The first natural disaster is hurricane or tropical cyclones. So how hurricane is formed? Hurricane starts with warm water in the equator. This warm water evaporates and creates moist air. It also needs wind. Wind causes most moist air to rise into atmosphere and begins to cool and form clouds. As this moist air continues to rise, wind blows in circular pattern around center, and once the speed of this spinning wind reaches 74 miles per hour, a storm turns into hurricane. And hurricanes are categorized according to wind speed, category 1, 2, 3, 4, 5. And category 5 is the most dangerous form of the hurricane, with the speed of more than 150 miles per hour. This figure shows the number of the tropical cyclone from 1850 to 2000, and you can see that the number of TC tropical cyclone has progressively increased. Also, SST or sea surface temperature has also increased, which is a necessary component to form hurricane. So there is a direct association between sea surface temperature and number of tropical cyclone. The next natural disaster is a flood because of sea level rise. According to IPCC, global sea level rose 3 millimeter each year in 10 years from 1993 to 2003. It is projected that Arctic Ocean will be ice-free before mid-century, which can endanger habitats of many animals. It is also projected that the life of 36 million people will be under the risk of flooding by the end of this century. Some lowland countries like Vietnam, Egypt, Bangladesh will be highly affected by flooding. And in the United States, lowland areas such as Florida and in particular Key West will be highly affected. So this website, globalfloodmap.org, provides interactive maps of flooding. So if you go to this website, you can you can enter values. What happens if sea level rise by, for For example, 6-inch, 18-inch, 100-inch, and 1000-inch. And which areas, you can see which area will be below the sea level. Here you can enter any other values for the inches, and you can see what areas will be affected by the sea level rise. And also here you can see there is, when you select something and then when you click on that, you can see number of people flooded for each country. And not only it is based on the country, it can also be based on the area. For example, in the United States, it's based on the area, it has provided the number of the flooded people. Another natural disaster related to global warming is increased number of dry days. Here is the result of simulation that indicates the duration of dry period in 20 years between 2071 to 2100 compared to the number of duration of dry period in 30 years between 1960 to 1999 as baseline. So you can see most part of the world, especially close to equator, will see increments in the duration of dry days. And model estimation suggests that some areas will have more than 50% to even 100% increase in duration of longest dry period. Now let's move on to talk about the indirect effects of global warming on human health. And indirect effects of global warming refers to the impact of global warming on the life of animals, insects, vegetation, and other environmental factors. And main categories are vector-borne disease, waterborne disease, allergic illness, and malnutrition. Let's start with the vector-borne diseases that you are familiar with. That overall, warmer temperatures and higher humidity can expand geographic range and seasonal activities of insects and rodents. As you remember from Lyme disease lecture, we discussed that in the spring and summer of the second year, the risk of human exposure to Lyme disease tick was highest because of nymph activities in spring and summer. And this shaded area may expand to fall and even winter because of the global warming, which indicates more exposure to nymph, resulting in a higher number of infected people. And this map shows climate suitability of malaria transmission in Zimbabwe in the year 2000 as a baseline for comparison. So the red color in this map shows the areas that are more than 95% suitable for malaria transmission. In the year 2000, the red area is kind of restricted to the north central of Zimbabwe. But according to model prediction, the red area in the year 2025 expanded to the southern and eastern part of the Zimbabwe in the year 2025. And in 2050, even larger areas are suitable for malaria transmission. And finally, in 2075, almost the entire country except for southernmost parts are suitable for malaria transmission. That's for vector-borne diseases, because as the temperature increases because of global warming, it provides suitable condition for malaria mosquitoes for breeding and activities. Another indirect impact of global warming is that the waterborne and food-borne diseases will become more prevalent. For example, because of drought, there will be insufficient water for hygiene and sanitation, like for washing hands or disposing feces, which results in the spread of disease like cholera, diarrhea, hepatitis A, and typhoid. Or floods can wash away and spread pathogens and chemicals into water. That's why you should never drink flood water or food that came into contact with flood, because it may contain infection agents, which in turn can cause intestine infection. This figure shows the association between daily temperature and daily diarrhea hospital admission in Lima, Peru. You can see in days with high temperature, there is a higher number of hospital admission because of diarrhea. So here we have higher number of the admission to the hospital, and here we have higher temperature. Also here we have another peak. But in lower temperatures like here, and here, you can see we have lower number of the admission to the hospitals because of the diarrhea. Also, the results indicated that for every degree centigrade increase in temperature, hospital admission due to diarrhea, which is a waterborne disease, is increased by 88%. The next indirect effect of global warming on human health is allergic diseases. As you know, one of the possible reasons for global warming was increase of greenhouse gases such as carbon dioxide. And carbon dioxide is a result of human activities like emission of fossil fuels. So, and in higher level of carbon dioxide, plants grow faster and produce more pollen and extend pollen season. And pollen production causes allergic diseases or can exacerbate your allergy. If you remember, one of the respiratory diseases sensitive to allergy was asthma, which was inflammation of airways because of anything that can cause allergy, like pollen. So that's a possible reason of the increase in the frequency of asthma in children. And finally, malnutrition. According to Schneider, for about 1 to 3 degree increase in global temperature, the productivity for some cereal decreases in low latitude. And low latitude means areas close to equator. And the productivity of some cereals will increase in high latitude like Russia and Alaska. Also, severe weather conditions like floods, droughts, and hurricane can destroy agricultural land, leading to poverty and insufficient food for some population. This graph shows the general relationship between temperature and photosynthesis, which is the process by which plants make food from sunlight, water, and carbon dioxide. So you can see in temperatures like 20 degrees, for every 2 degree increase in temperature, photosynthesis activities will increase, which provides more crops, more food. And the peak rate of photosynthesis is almost close to room temperature. But at very high temperature, like close to 35-40 degrees centigrade, for every 2 degree centigrade increase in temperature, photosynthesis will decrease, which results in lower crop yields because the enzyme destroys at higher temperatures. And according to Field and Lobel, 1 degree centigrade increase in global mean temperature will decrease global crop yields by 6 to 10%. And this map by Fisher and colleague provides a prediction of the effect of climate change on rain-fed cereal for the year 2020. According to the map, some areas will have 100% decrease in cereal production. They are mostly in low latitude, closer to equator. On the other hand, some areas in higher latitudes like Russia and Alaska will have increasing crop yields. These areas which will have higher decrease in crop production are also have high population density, like South and Southeast Asia, Central Africa, and northern part of South America, suggesting that there will be less food for growing population, and they will become poorer and poorer